Welcome to Next Level Tutorial. In today's session, we'll explore two key topics from the kinematics module. First, scalar and vector quantities, and second, distance, displacement. By the end of this tutorial, you'll have a clear understanding of these fundamental concepts and how to apply them effectively in solving problems. Instead of diving straight into the content of each topic, we'll start by looking at actual past examination questions. This approach helps us understand exactly what's expected in the exam and allows us to focus on the most relevant knowledge from the textbook. This will equip you with the skills to confidently tackle similar questions in your own exams. Let's get started and take your understanding of physics to the next level. The first question is relatively straightforward and focuses on the topic of scalar and vector quantities. It involves traveling in two different directions and requires us to calculate the magnitude and direction of the car's resultant displacement. If we carefully examine the question, we see that it not only specifies the distance traveled, but also includes the direction of the journey. This detail highlights two key learning points. The first key point is understanding the distinction between scalars and vectors. If we consider only the distance traveled and ignore the direction, we will arrive at an incorrect answer. The second key point is differentiating between distance and displacement. This question specifically asks for displacement, which is a vector quantity. If we mistakenly calculate the distance instead of the displacement, we will arrive at an incorrect answer. Understanding the difference between these two concepts is critical for solving problems in kinematics accurately. In physics, we often deal with two types of quantities, scalars and vectors. So, what's the difference? Scalars are quantities that have only magnitude, just a number. For example, the speed of light is approximately 299,792,458 meters per second. The mass of Earth is approximately 5.972 times 10 to the power 24 kilograms. The energy from a single uranium-235 fission reaction is approximately 3.2 times 10 to the power of minus 11 joules, or the temperature of the sun's core is approximately 15 million degrees Celsius. They tell us how much, but not which direction. Now, let's talk about vectors. Vectors have both magnitude and direction. For instance, a car moves at 20 meters per second north. A force of 50 newtons pushes an object upward. An electric field is 10 newtons per coulomb downward, or a plane flies at 300 kilometers per hour to the east. Here, the direction matters just as much as the size. So remember, scalars like speed, mass, and energy only give magnitude, while vectors like velocity, force, and electric fields give both magnitude and direction. Now, let's return to question 1. We have a car traveling in two different directions. First, it travels 60 kilometers north and then 80 kilometers east. Before we proceed further, note that these are vectors rather than scalars, as both magnitude and direction are involved. To solve this problem, let's start by drawing a diagram to visualize the distances, directions, and resultant displacement. Begin by marking the north direction on the diagram using a compass-like cross. Next, draw the first leg of the journey, representing the car traveling 60 kilometers north from the starting point. Then, from the endpoint of this leg, draw the second leg, representing the car traveling 80 kilometers east. Let S label the starting point, intermediate point, and destination as A, B, C respectively for reference. We'll now calculate the distance between A and C. Using the Pythagorean theorem, AC squared equals AB squared plus BC squared. Using the calculator, we can find that AC equals 100 kilometers. Now the angle is also required to indicate directions. Let the angle BAC be theta. Using the equation, tangent theta equals BC divided by AB equals 80 over 60. Pressing the calculator, we will see theta is approximately 53.13 degree. Now we have all the values required to answer the questions. Before we jump straight to the answer, let's consider several quantities we can calculate just for our learning. The first quantity is the total distance traveled, which is 60 plus 80 equals 140 kilometers. Note that this scalar sum and no direction is not considered. The second quantity is the distance between the origin and destination. This is the straight line distance, AC, which is 100 kilometers, as calculated earlier. Again, this is a scalar quantity with no direction. The third one is the displacement of the entire journey. This is a vector quantity, meaning it must include both magnitude and direction. The displacement is 100 kilometers at 53.13 degrees east of north. Finally, referring to the question, the required answer is the displacement of the car. Therefore, the required answer is the third quantity we have calculated, which is 100 kilometers at 53.13 degrees east of north. Note that in an actual examination, unlike the question we have here, it may simply ask for displacement without explicitly stating both magnitude and direction are required. However, we should always remember if it asks for a vector, which is displacement in this case, both magnitude and direction must be provided in the answer. Conversely, when a scalar quantities like distance is asked, only the magnitude is needed and no direction should be included, or we may risk losing marks. Let's summarize what we've learned today. First, we explored the difference between scalars and vectors. Scalars require only the magnitude, while vectors require both magnitude and direction. It's crucial to carefully read each question to determine whether it's asking for a scalar or vector quantity and ensure your answer includes the appropriate elements. Second, we discussed the difference between distance and displacement. We practiced performing calculations for both, using a simple example. We also noticed that multiple quantities, like total distance, resultant displacement, and direction, can be calculated from the same diagram. Again, always pay close attention to the specific requirements of the question to provide an accurate answer. Thank you for watching this tutorial. That's all for today. Next time, we'll build on this concept by exploring speed and velocity in similar problems. See you next time.